So when Abir mic starts working, then we'll start. Okay, because I can see that her mic is not working. Now it is. Hello, Abir. Assalamu alaikum. Hello, Abir. Can you hear me? Hello, Abir.
Yes,
Maybe
sir.
she's. Yes, yes. Hello, assalamu alaikum. Hi.
Welcome, salam, sir.
Yeah. So look who is here, back from the trip.
Tejasvi, sir.
Yeah, Tejasvi is back. Yeah. So and she was telling us about. So she went to Seoul, Korea, in a survival group camp. So all the all the students from the different worlds, not the different world, but different countries came and good. It would have been a very nice trip. Good good to hear. They just yeah. So you can tell about it to Abir and Amira and Faz, right?
Yes, so
Okay. So where were we? We were uh, we were in the introduction to trigonometry, right? And yeah, so we okay, so we completed this. Did you guys try the second question? Did you guys complete this one? Yes, yes. Abid, Faiz, and Amira.
Completed, sir. All
Completed.
the options of question number 2, yes, sir.
Yeah. So I am asking that did you guys complete this one also? Second one, because it is only the values that we have to put, right? So that is why I just skip these problems. So what I will do is that I will start a new topic, right? And you guys try these questions. So these are value-based questions. We have to put the values of these trigonometric ratios. Okay. Is it okay for you guys?
Yes, sir.
Yes, sir.
Yeah. So please try these questions. So because if I start this question, then they just will say that. So I will come back to this question later. Now, in today's class, let me start the next topic. Right. Okay, Tejasvi. So you have to bear with us for some moment. You have to accept some things for this class, right?
yes, sir.
And you have also done it in your school, so I guess that would be helpful. So
No,
just
sir, this chapter is not in my school actually.
okay now, now then we have a problem. Okay, so just remember that we have a right angle triangle. Okay, and in right angle triangle we have some hypotenuse, and if we take this angle, then this is the perpendicular and this is the base, right? So we have some trigonometric ratios which relates the angle with the sides. So sine theta is what, Amira? What is sine theta? Yes.
Perpendicular by hypotenuse.
Yeah, sine theta perpendicular. Phase, what is cos theta? Yes, phase.
Yes, cos theta is based by hypotenuse.
Yes. Base by hypotenuse, and tan theta is what? Abir. Yeah,
Perpendicular by base.
perpendicular by base, and then we have the rest one. So the rest ones are cosec theta, which is reciprocal of hypotenuse by perpendicular. Cos theta reciprocal is sec theta, which is hypotenuse by base, and then tan theta reciprocal is cot theta, which is base by perpendicular. So keep this in mind, right? Tejasvi, so just remember this point. Okay,
Yes, sir.
take the screenshot and then go ahead.
I have noted down, sir.
Good, good. So now we have this three trigonometric identities, right? Just like the algebraic ones. So the in algebra we have these kind of identities, right? So these kind of identities similar to this in trigonometric we have some special identities. So first one relates sine theta to cos theta. So trigonometric identity. So this relates different trigonometric ratios. Okay, so first one is this one. Sine square theta plus cos square theta. This is equal to 1. This is the first trigonometric identity. Okay, and how can we prove this? So the proof is very simple. We know that what is sine theta. So what is sine theta, Abir?
Perpendicular by hypotenuse.
So perpendicular by hypotenuse, and this is square. And then cos theta is base by hypotenuse. This is square. So this is our LHS, right? So if we square these two, so we'll get p square by h square and then b square by h square. So if we take the LCM, this is h square and then this is p square plus p square. So Tejasvi, can you tell me what is perpendicular square plus base square? Remember the Pythagoras theorem? Yes.
PV square.
Perpendicular square plus base square. What is Pythagoras theorem? So we have this perpendicular, we have this base and this hypotenuse. So Pythagoras theorem says that perpendicular square plus base square, this is hypotenuse square. This is the Pythagoras theorem, right?
Yes, sir.
So this is hypotenuse square divided by, so this is 1, which is equal to RHS. So if you guys have any doubt, please ask. Otherwise, please note it down. So this is the first identity. Amira has any doubts?
No,
No,
sir.
sir.
Okay, please note it down.
Done, sir.
Done, Amir. Good. What about rest of you guys?
Done, sir.
Done. Amira and Faz, what about you guys?
Yes, sir. Done.
Yes, Amira, noted.
Yes, sir.
Okay, now the second identity is it relates sec theta and tan theta. So sec square theta minus tan square theta equals to 1. One moment, right? Okay, so this one is the second identity, right? Now, What is sec theta? Do you guys remember? Yes, Amira, what is sec theta?
Sec theta is hypotenuse by base.
Hypotenuse by base, right? So good. This is hypotenuse by base. And then tan theta is what? This is perpendicular by base, right? So we have, this is LHS. So we have hypotenuse square by base square minus perpendicular square by base square. So base square is common, and we have hypotenuse square minus perpendicular square. So what would be this, Tejasvi? What would be this?
So we
Yes.
should use Pythagoras theorem again.
Yeah, so p square plus b square is h square. So what would be h square minus p square?
B square.
B square, right? So b square by b square, again one which is RHS, right? So this is the second added, right? Now let me also write the third one, and then you guys will know that. So third one is, it relates cosec theta and cot theta. So again we can prove this, right? So this is h square by b square minus b square by p square, right? So h square by p square minus b square by p square, again b square LCM, and h square minus p square, which is p square by p square, which is 1, which is RHS. So this is the third identity. All these three are very important. So we'll the next exercise is all about these three. Okay. So please note these two. And Amira and Faiz. So in the previous class, I assigned you some homeworks, right? What happened to that, guys? Yes, Abir, Amira, and Faiz. What about the homeworks, guys?
Sir, I'm sorry, I have not sent it because I'm revising for my maths exam coming up.
Oh, maths exam. When is that?
Like the exams are starting from the 27th. So,
Okay, and what is the syllabus of maths exam?
so quadratic equations and triangles.
Quadratic equation and triangle, right? So triangle is
Yes, sir.
what? Sixth chapter.
Yes, sir. And quadratic equations 4.
Yeah, so 4 and 6. So this we have completed so many times, right?
Yes, sir.
Okay, so you practice the NCRT problems and the assignment problems also, and practice a lot. Whenever you find any problem, so you can ask, right?
Yes, sir.
In the middle of the class, you just stop me and ask, sir, this is the problem, and just tell me about the question. Okay.
Yes, sir. Sure.
And yeah, please tell me, or if you know, so when is that? When is the maths exam? After 27, when is the maths exam? Or is
Sir,
it?
I did not got to know till now. So when I will get in, I will inform
Yeah,
you.
yeah,
Sure.
yeah. Please inform. Right.
Yes, sir.
Okay, because in the backup class we'll start at the quadratic equation, so that would be here. Okay, noted, everyone.
Yes, sir, noted.
Yeah.
Yes, Tejasvi and
Yes,
Faiz.
sir. Done.
Done.
Yes,
Okay.
sir.
So you guys write it so many times, right? And remember these things. So first one, then second one, and then third one. This is the important three identities, and then this relation. Okay, and also this one, reciprocal one, and then this one. Okay, so we have to remember these, only these conditions we will require, right? So remember these, how many? Three and four, five, six, seven. So seven properties. Okay, and remembering this, let us do some questions from the exercise. Okay, so what is the first question we have? So express the trigonometric ratio sin A, sec A, and tan A in terms of cot A. Okay, so the first question that we have. So the idea of this question is that whatever we know directly, we calculate that first. So what do I mean by that? So what do I have? I have the first identity and the second one and the third. So these are three things I know, right? And I have to write trigonometric ratios sin A, sec A, and tan A in terms of cot A. So I have sin A, I have sec A, and I have tan. And all these three I have to write it in terms of cot A. So which one I can directly write? Which one I
Tan,
can
tan
tan?
A.
Tan A, right? So good. So tan A I can directly write as
1 by cot A.
1 by cot. Okay, good. So now this is completed. And we have these three ones, right? So from these three, in which do I have the cot theta? In in which of these three equations I have cot theta? Yes,
Third one,
third one, right? So in the third one, I have the cot theta. So from this, I can calculate what?
cot, cot A.
No, no, I have to write it in form of cot. So I can I know this one. I can calculate this cosec A, right? So let us write this equation. Cosec A square A minus cot square A is 1. So I can calculate cosec A. Is this clear? This is 1 plus cot square A. So cosec A is root of 1 plus cot square. So is this clear?
Yes, sir.
Yes, sir.
Now, from this cosec A, what is the thing that I can calculate?
Sine.
Sine, absolutely right. So sine A would be what?
1 by cosec A.
1 by cosec A. So Tejas, you have to bear with us, right? Few classes would be, so you are just coming from the vacation, so few classes would be difficult for you, right? So just, yeah. Just get the flow and then we'll be back in form, right? Okay,
Yes,
so
sir.
1 by 1 plus cot square. Now we have written sine in terms of cot square or cot A, right? So this one is also completed. Now which one is the left one? Sec. Okay. So tan A is given. Tan A is given, and from tan A, what we can calculate? From tan A, what we
Sec.
can
Sec theta.
sec theta we can calculate. Absolutely right. So we have sec square A minus tan square A. This is 1, right? So sec square A would be what? 1 plus tan square A. And sec A is what? This is root of 1 plus tan.
1 by cot A.
Yes. So we can write this as 1 plus 1 by cot square. Clear up to this point?
Yes, sir.
Okay. So yeah. So oh, we already calculated yeah. So what we can do is that we can stop at here, or we can simplify this more. So to simplify this more, this would be cot square A plus 1 divided by cot square A and root of. So this is root of 1 plus cot square A divided by cot A. So we can write this one, or we can write this one. Both are correct. So this is the third. Any doubt in this question, guys?
No, sir.
Yeah, we have to use just these three equations, and then we can find out any other, right? So please note it down, and then we'll do the next question. This was the first question, right? Express the trigonometric ratio sine A, sec A, and tan A. So tan A in terms of cot A, sine A in terms of cot A, and sec A in terms of cot A. So this was the question. Please note it down, and if it is not clear, then please ask me again. Yes, Faz, Tejasvi, Amira, clear to you, or any doubt? You guys have any doubts? Yes, guys, clear.
Yes, sir, it's clear.
So can you explain the third one, please? The sec square A minus tan square A.
Oh, okay. This third one.
Yes, sir.
Okay, so what we can calculate, right? So either from okay, so either from cosec theta, right? We want to calculate sec theta. Okay, so we have to calculate sec A in terms of cot A, right? But what do we know from here? We can calculate sec in terms of tan, right? And tan in terms of cot A we have calculated. So we can calculate the sec theta in the form of tan theta first. This is the first idea. So we just wrote this sec square A minus tan square equals to 1, right? And we put the value of tan. So value of tan was what? 1 by cot. So this we put, and then we got the answer in the form of, so this sec A in the form of cot A. This was the idea. Clear?
Yes, sir.
Or what we can also do is that we can calculate Yeah, so that would be complicated. So we can calculate cos. We can calculate cos A first and then calculate sec A. But yeah, yeah, you guys can calculate in that way also. So you guys note it down and then I will tell you to use the other one to calculate. Right, we can use any method to calculate these ratios. And whenever you guys want me to scroll down the screen, guys, please tell me.
Noted, sir.
Okay.
Done, sir.
Whenever you guys have completed, please tell
Noted, sir.
Sir.
me. Noted. Tejasvi, Amia, Faiz, what about you guys?
Yes, sir. Doctor.
Done.
Noted.
Noted, sir.
Okay, so what I was telling you guys that we can also calculate, right? So we can also calculate sec A in terms of cos A. So as we know that sine A is what? Sine A is 1 plus cot square A, okay? And from sine A, what can I calculate?
Cos.
Remembering cos, absolutely right. Good. So we can calculate cos, right? So let us, so we know that sine square A plus cos square A is 1. So we can calculate cos square, right? So cos square A is 1 minus sine square A, which is cos A is root of 1 minus sine square. Now we can put the value of sine in here, right? So putting this value, what we will get? We will get 1 minus square root of this, which is 1 plus cot square. I am directly writing this, right? Because square of square root is this one. So now if we take the LCM and we simplify this, so this is 1 plus cot square A and minus of 1 divided by 1 plus cot square. So 1 cancel and what do I have? I have root of cot square A divided by 1 plus cot square A. So what is this? Cot square root is cot A divided by root 1 plus cot square A. So I have calculated cos A. What would be sec A?
1 by cos.
1 by cos. So I take,
Reciprocal.
yeah, so I take the reciprocal whatever I have got. So sec A is 1 by cos A, which is reciprocal of this. So 1 plus cot square A divided by cot A. So did I get the same result?
Yes, sir.
So we can use any method, right? We can use any identity in our hand, and it all depends on us. So whichever way we want to calculate. Okay. Yeah. So do you guys also want to note this down? This was just to show that we can use the other way also. So do you guys want to note this down? Yes.
Noted.
Noted. Okay, so now let us do the second question. So Amira's turn is the second question, right? Amira or Tejasvi? So who joined first? You or Tejasvi? Tejasvi joined first, right?
Yes, sir.
Yeah, so now you are back, so the turns are right again. Okay, everybody noted this one?
Yes, sir.
So first question for Tejasvi. Or we should not bother you. This is your right. First class.
Can I do next time?
Yeah, that is why. That is why. Okay, yeah. So okay. Okay, so now then it is Amita's turn, right? So remember, whatever we can directly find out, so we calculate that first. So the second question, Amira, write all the trigonometric ratios of A in terms of sec A, right? So now we have to write it in terms of sec A. So the first trigonometric ratio that we can directly calculate, what is that? Yes, Amira. What is the first thing that you can directly calculate?
Cos.
Cos, right? Absolutely right. So cos A would be what?
Base by hypotenuse.
No. In terms of sec A.
Oh,
So you are saying that we can directly calculate from here, right? So first we write the reciprocal one. You are correct. So what is cos A?
so cos A would be tan.
So cos A would be tan. Okay. So whose reciprocal is sec A? Yeah. What is sec A in terms of perpendicular base and hypotenuse?
Cos.
Mm, so are you saying that it is reciprocal of cos? Yes. Okay,
Yes, sir.
so oh, okay, so this is are you saying this is 1 by cos?
Yes, sir.
Good. If any confusion arises, so just think about this, that we have sine theta, which is p by h, cos theta, which is b by h, and then tan theta, which is p by p. And then we have cosec theta, which is h by p, and then sec theta, which is h by b, and then cot theta, which is b by p. So any confusion, whenever any confusion arises, just think about this. Okay. Then you can
Yes, sir.
directly say that this is b by h, this is h by p. So this is 1 by cos theta is 1 by sec theta, or sec theta is 1 by cos theta. So in this way we can figure it out. Okay. So in
Yes,
these,
sir.
yeah, in these kind of question, we always write the reciprocal ones. So you were right, but in the middle you got confused, right? So you told the right answer. Right? So do not get confused, right? Be confident in your answer. Okay, Amira.
Yes, sir.
So this is 1 by sec. Right. This is what you were telling us from the go, right?
Yes, sir.
Now, looking at the equations that we have, right? Which one has sec theta?
Sec square theta minus tan square theta.
This one. So from this we can calculate what? We know sec, right? We know one. So what we can calculate? This one, right?
Yes, sir.
So tan square A would be sec square A minus 1 would be tan square, right? So tan square A is sec square A minus 1. So tan A is root of sec A minus 1, right? So this is the second one. This is first one, A, B. We have calculated the tan also. So we have calculated tan, and from tan, what we can calculate? What is the reciprocal one?
The tan reciprocal would be cot.
Cot. So we can calculate cot from here, right? Cot A is 1 by tan, right? So 1 by sec, this is square, sec square A minus 1. So we have calculated cos, we have calculated tan, we have calculated cot. Now what is remaining? Sine and cosec are remaining, right? Correct?
Yes, sir.
So using, we want to calculate sine. If we calculate sine, then we can calculate cosec, correct?
Yes, sir.
So we know cos. So from cos, between these two, what we can calculate from cos? So getting back to the equations that we have cos. From cos, what we can calculate?
Sine.
Sine, right? So let us write this identity. So we have sine square A plus cos square A is 1. So sine square A is 1 minus cos square A. So sine A is root of 1 minus cos square. And cos square A is what? What is cos A? 1 by sec A. So this is 1 minus 1 by sec square, right? We take the LCM. So this is 1 by 1. So this is sec square A minus 1 divided by sec square, right? So in the denominator, the root is outside. So this is what we get. Now we have calculated the sine also. So now what we can calculate? If we have sine, what we can calculate?
Cosec.
Cosec. So what would be cosec A? Yes. What would be cosec A, Amira?
Cosec A would be 1 by sine A.
1 by sine, right? So then we take the reciprocal of this quantity, which is sec A divided by sec square A. So these are the rest of the trigonometric ratio, all in terms of what? All in terms of sec A, right?
Yes,
So
sir.
any doubt, guys? Abhi, Tejasvi, Faiz, any doubt? Yes, guys.
Sir, is it necessary to find the LCM and all? Is it okay if we just find it as root 1 minus 1 by sec A, sec
Yeah,
square
yeah,
A?
yeah, yeah, yeah.
That's
This
okay.
one is completed, but we don't know the examiner, right? So
Yes, sir.
yeah, so we can. This is completed because this is also in terms of sec, right? So I guess this is also completed, but yeah, we don't know the mind of the examiner, so we should completely solve this, right?
Yes, sir.
Okay. Yes. Any doubt, Tejasvi and Faiz?
No, sir.
Okay. So what I will tell you guys that you guys practice. So I will give a homework, right? So I will ask you guys to write all the trigonometric identities in form of tan. So this would be your question, right? Try this question. So the idea is that firstly we write the reciprocal one. We write the reciprocal one, then we write the identity one. Okay. And then from this, whatever we got, then we take the reciprocal of that one. So in this way, we can calculate all the identities, right? So this is what I'm doing. I first write the reciprocal and then the identity, and then from identity and then the reciprocal and then the other identity. So these are the methods. Okay. You guys quickly note it down and then we'll do the next question. So next question, whose turn is it? Abhi, right?
Sir, can you scroll down, please?
So Tejasvi, when you were here, so what chapter we were doing?
Triangles, sir.
Okay, so how many exercises did we finish when we were there? When you
Just a
left?
minute, sir.
Yeah, because after we have also the backup classes which are happening on Monday and Wednesday. So please be there. I am currently I am doing the linear equation. So then I will
Okay.
start quadratic. Yeah, then I will start quadratic and after that will be APN also. Okay, whenever you guys have finished noting, please tell.
Done, sir.
Done. Abhi,
Noted, sir.
Amira, you did this problem. So, Faiz, what about you?
Yes, sir. No.
Done noting. Okay, so okay, what is the next question we have? Okay, so this question is for us. Third one. So we have 9 6 square A minus 9 tan square, right? So what should we do first, Abir, in this question?
Sir, 9 is
Yeah,
common.
good.
So,
Yes, absolutely right. And then,
and then from the identity, sec square A minus tan square A is 9 is 1.
so this is 9. Good.
9.
Okay, good. So so this is the answer, right? So everybody understood?
Yes,
Yes,
sir.
good, good. So yeah, please note it down. And then second question is also for Abir, right? This third question we are doing. Okay, so now Okay, you did one problem, so second question is for Faz. And whenever you guys have noted it down, please tell.
Done, sir.
Then, ASV, Amira, and Faz, what
Done,
about you
sir.
guys?
Done, sir.
Okay, yeah. And the idea of this exercise is that, so write all the trigonometric function or ratio in sine and cos. This is the idea of this exercise, right? Whenever it is given, so this is the first idea. When we don't know anything about it, so we write all the ratio in terms of sine and cos only, and then we simplify. Other than that, whenever we have only, right, so whenever, let's say, we have these kind of questions, so let's say, okay, we will talk about that later. But the preliminary idea is that we write all in terms of sine and cos. Okay. So remembering this, let us solve this second question. So 1 plus tan theta and plus sec theta and 1 plus cot theta minus cosec theta. So in terms of sine and cos, what is tan theta, Faz? What is tan theta in terms of sine and cos? Faz, this question is for you.
Sine theta by cos theta.
Yeah.
Tan theta is
Yes, absolutely right. And then what is sec theta?
1 by cos theta.
Yes, 1 by cos theta. And then we have cot theta. So what is cot theta? In terms of sine and cos, what would be?
Cos theta by sin theta.
Yes, good. And then the last one, this is sine theta.
1 by sin theta.
So now what we do is that we simplify these terms, right? So let us simplify this, take the LCM. So this is 1 plus, this is cos theta, right? Cos theta plus sine theta and plus 1. And then we have sine theta plus cos theta
Minus 1.
and this is what, sine, right? So can you guys identify the identity that we have in these two terms? Faz, can you identify the identity? Let me write it in this way. So first is sine theta plus cos theta plus 1. And okay. And then the other one is sine theta plus cos theta minus 1. So can you identify the identity? Let's say that this is A, this is B, this is again A, this is B. So what is this identity? Yeah, what is this identity, guys?
A plus B into A minus B.
Yes, absolutely right. So we have A plus B into A minus B, right? So we can write this as sine theta plus cos theta whole square, A square minus B square. Am I correct?
Yes, sir.
So this is A square plus B square and plus AB minus 1 and then cos theta into sine. So what is this, guys? What is this?
1.
This is 1, right? So this is 1 plus 2 sine theta cos theta minus 1 and then cos theta sine theta. So this is cancelling and we have 2 sine theta cos theta divided by cos theta and sine. This is cancelling and we have. Okay, so one student is waiting in the waiting room. Oh, she has joined. Okay, so you guys quickly note it down and then we'll yes. Yes, hello Aisha, please wait for 1 or 2 minutes. Okay.
So what is this written? Sine theta plus cos sine square theta plus cos square theta plus 2 sine theta.
Yeah,
And
2 sine theta into cos theta. A plus B whole square, right? A square B square plus 2AB.
so this is into cos theta.
Yeah, 2 sine theta into cos theta and in the last we have minus 1. So
Yes.
yes, Aisha, please wait for few 1 or 2 minutes. Okay.
Done, sir. Noted.
No, noted. And do you guys have any doubt in this question?
No, sir.
Okay, so Abhi, Tejasvi, Amina, and Faiz, you guys on Monday. Okay.
Yes, sir. Allah Hafiz.
Allah Hafiz. Bye, guys. Bye. Bye.
Thank you, sir.
Yeah, bye, bye,
Yes,
bye.
sir. Assalamu alaikum, sir.
Walaikum salam. Bye, guys. Bye. Yes, hello, Aisha. Assalamu alaikum.
Walaikum salam, sir. How are you, sir?
I'm good. How are you, Aisha?
I'm good, sir.
Okay, so before we start this class, right, let me ask a couple of questions first. So, in your school, how much they have finished?
So we finished until arithmetic progressions.
AP. So that is fifth chapter, right?
Yes, sir.
Good, good. And so, okay, so first to fifth, and they have not started the probability or any other chapter, right?
No, sir.
Yeah, they are going serial wise. So from first to fifth chapter. Okay. Good.
Yes, sir.
And so is the vacation still on or are the vacations over?
Sir, there's still one more week.
There's still one more. Okay. Yeah, and so I have 2 batches, right? In one batch I'm doing, as you can see, trigonometry, and in the other batch I'm doing probability. And I have also this backup classes. So in the backup class I'm doing currently linear equation in 2 ways. Okay.
Okay, sir.
So what I will do today is that I will talk about polynomials so that we have the preliminary ideas of what we do, right?
Yes, sir.
Yeah, we have only 1 week, so we have to complete 5 chapters. Okay, let's see how much we can complete, right? I can also take some extra classes in Saturday and Sunday so that we can finish these chapters quickly, right?
Okay, sir.
So after your school reopens, so there would be some examinations, right?
Yes,
So
sir.
can you tell me that how many chapters will come in that exam?
Sir, as of now, when the school reopens, they'll take the 6th chapter.
Oh,
And then,
okay. So first they will complete the 6 chapters, 6th chapter, and then they will ask from all the 6 chapters, right?
they'll complete statistics and then they'll ask all of them together.
Oh, okay. So statistics. Oh, they will do statistics first and then probability. So
Yes, sir.
okay, okay. So after sixth is triangles, right?
Yes, sir.
Okay. So let me see. Yeah. Hopefully I will take some backup classes and extra classes and then before your school completes the statistics, then I guess that you will be able to complete those chapters, whatever it is. Okay.
Okay, sir.
Yeah. So for today's class, let us start with the poly. Right. Okay, so okay, so one. Yeah. So what do we understand about poly? Right.
Yes, sir.
Right. So we can see that it is made up of two words, right? Poly and nomial. So poly means one or more,
Mm-hmm.
and nomials means terms.
Okay, sir.
So whenever we have one or more terms, then that is called the polynomial, right? So
Yes, sir.
this definition is based on the number of terms that we have, right? So let's say that I have something like ax square or something like 3x square plus 5x plus 4. So how many terms are there in this polynomial, right? How many terms are there?
Three. Three terms are there.
Three terms are there, right? So
Yes, sir.
this would be called a trinomial.
Yes, sir.
So tri meaning three and nomial meaning terms. So this has three terms, right? If I write this term, so how many terms are there for this one?
A single term, sir. So it's linear.
Right. So a single term, we have only one term. So this would be called a mono. Okay, mono meaning one and then nomial meaning term. So this is a mono. So on the basis of number of terms, this is how the polynomials are defined. Okay, so on the basis of number of terms, so let's say that, and then the name of the polynomial. So if we have one term, then it will be called a mono.
Okay, sir.
And if we have two terms, then it will be called a binomial. And if we have three terms, so then it will be called a trinomial, as we saw. Right. And then if
Yes,
we
sir.
have, so these are, and then so on. These are called, all these are called polynomials. Okay.
Okay, sir.
And but there are some characteristic of polynomial, right? So there are mainly two basic characteristics that defines the polynomial, right? So this
Mm.
definition was based on number of terms, but we have certain characteristics. So what are those characteristics? First one is that first one is that a polynomial can't have a negative power or can't have negative powers, right?
Yes, sir.
So let's say that we have something like these terms. So let's say we have 3x plus 4 by x cube plus 5, right? So this is a trinomial, but what is the power of this term in here?
3
So this is in
minus
the,
3.
yeah, this is in the denominator. So if we write it in one moment, one. Oh, so sorry about that. So we have this, which is -3 and +5, right? So
Yes, sir.
negative power on the variable, I should write. Right? Negative powers on the variable. Okay. So this has power 1, right? But this has power minus.
Mm.
So this will be not a polynomial, right?
Yes, sir.
So if I ask you this, that we have this one. So is this a polynomial?
No, sir.
Okay, so are you sure?
Yes, sir.
Okay, so whenever we have these kind of scenario, right? So is this a simplified term?
No, sir.
So first we have to simplify, right? From
Yes,
here,
sir.
by yeah, so from here it is looking like not a polynomial, right? But when
Mm.
we simplify this, so when we simplify this, so then what we get? This is x cube and then 5x and then x. So this is what? X square cancels and we have 1, and this is 3x plus 5x. Now can you tell me, is this a polynomial?
Yes, sir.
So this was a diversion, right? This was a decoy. So we have
Mm.
to first we have to simplify, and then we can confidently say that whether it is a polynomial or not, right?
Okay, sir.
So this is the first characteristic, and the second condition or the characteristic is that a polynomial can't have fractional powers on the variable, right? So if we have something like these terms, let's say 3x to the power 3 by 2 plus 4x square plus 5, right? So in here we can see that this is a fractional power.
Yes, sir.
So which means that this is not a polynomial,
Okay, sir.
right? So polynomials are defined like the number of terms, and then these are the two important conditions of a polynomial. Okay.
Okay, sir.
So the previous definition was based on the number of terms. Now we have another definition of polynomial. So, and that is based on the powers on the base. Okay. So to
Okay,
understand
sir.
that, yeah. So to understand that, first let us learn about the degree of the polynomial. Okay. So let's say we have a polynomial which is 3x 5 plus 2x squared plus 7. So this is a trinomial, right?
Yes, sir.
And what do we have? So what is the power of x in here?
5,
5. And in here, what is the power?
2,
2. And in here, what is the power?
0.
0, right? Because I can write this as 7 into 1. And I can write
Yes, sir.
1 as x to the power 0, right? So this is power 0. Good. So now we can say that what is the highest power on the variable?
5.
So highest power on the variable is 5. So this is called the degree of the polynomial, right? So degree of the polynomial is defined. So degree of polynomial is defined like highest power on the way.
Okay, sir.
So first we understood that on the basis of number of terms, what are the polynomials? Now, on the basis of degree of the polynomial, there are certain classifications of polynomials. So what are those? Let us understand about that.
Okay, sir.
So let's say that we have this polynomial, which is 3x plus 5, right? So what's the degree of this polynomial?
1.
1. So degree is 1. Absolutely right. So if degree is 1, so we call that a linear polynomial. Okay, so whenever we have a degree which is 1, so that would be called a linear polynomial. And how many variables are there in this polynomial?
2, sir. So it's binomial.
No, not the terms, but variable.
1.
Yeah. So we have only one variable, which is x. So this is linear polynomial in one way, right? And if I write a polynomial which is like 3x plus 4y plus 2, right? So what is the degree of this polynomial?
1, sir.
Again, degree is 1, but this is a linear polynomial, right?
In 2
In,
variables.
yes, absolutely right. So in two variables. Okay, similarly, if I have a polynomial which is like this, so 2x square plus 3x plus 4, right? So this is the polynomial. What is the degree of this polynomial?
2, sir.
Absolutely right. So degree is 2, right? So whenever we have degree which is 2, so this is called the quadratic polynomial. Okay, and similarly, if we have these kind of polynomials, it's 7. So in here, degree is 3. So this is called a cubic polynomial.
Okay, sir.
Right. So these are on the basis of degree of the polynomial. These definitions are on the basis of degree of the polynomial. The
Yes,
previous,
sir.
yeah, the previous definitions were on the basis of number of terms, right? But these definitions are on the basis of degree. So let us write that in the, so if we have degree, right, and in this side we have polynomial. So if we have degree which is 1, so this is linear.
Mhm.
If we have degree 2, so this is quadratic. And if we have degree 3, this is called cube. Right. So these definition are based on the degree of the polynomial. Right.
Yes, sir.
Okay. So clear up to this point.
Yes, sir. Clear.
Okay. So the next thing is about the solution. Right. So if we equate, let's say we have a quadratic polynomial, right? Let's say we have 3x square plus 5x plus 3. So this is a polynomial, and if I put it equal to 0, right? If I put the polynomial equal to 0, so then this would be called an equation, right? So this
Yes,
was
sir.
this was a quadratic polynomial, but if I write like this, if I equate it with the 0, so this will be called a quadratic equation, right? So
Yes, sir.
if I put it equal to 0, then I'll get the solution or the values of x where px is 0, right? So
Mm.
let me take a simple equation. Let me take a linear equation. So let's say that if I have a linear equation which is 3x plus 6, right? So if I put px equals to 0, then I will get 3x plus 6 equals to 0, which means that 3x equals to minus 6. So x is minus 6 by 3, which is 2. So x is minus 2. So you see, when I put px equals to 0, I'll get the value of x, right?
Yes, sir.
So these values will be called the zeros of the polygon. Why zeros? Because if I put x equals to minus 2 in here, so I'll get px equals to 0. Let us check that. So let
Okay,
this,
sir.
yeah, so let px is 3x plus 6. And if I put x equal to minus 2, so this would be 3 into minus 2 plus 6. This would be minus 6 plus 6, which is 0, right? So that is why
Yes,
minus
sir.
2 is 0 of the polynomial. But if I put x other than minus 2, will I get 0?
No, sir.
Right. So that is why we have we call these values as the zeros of the polynomial, right? And these are these are related with the degree of the polynomial. Okay.
Okay, sir.
So yeah. So relation between the zeros of the polynomial and degree of the polynomial. Okay, so if I have, as you saw in this example, that this was a linear polynomial, right?
Yes, sir.
So in the case of linear polynomial, how many zeros we got?
1.
One, right? So the relation says that the number of zeros of the polynomial, this is equal to the degree of the polynomial.
Okay, sir.
So if we have, let's say, a quadratic equation, so how many zeros would be there for quadratic equation?
2.
2, right? Absolutely right. Because the degree is 2, so we'll get 2 zeros, right? Similarly for
Yes,
cubic,
sir.
yeah, similarly for cubic, we'll get, okay, so this is completed. Now the next topic is understanding the zeros of the polynomial in a graphical way. So graphical representation of zeros of the polynomial. Right. So what you do is that we have, let's say, we have this x-axis and then we have this y-axis. Okay. So
Yes, sir.
we already know the coordinates of these axes. So let's say I have this one. This is 1, 2, 3, 4, 5, 6, and 7, and so on. This is minus 1, minus 2, minus 3, minus 4, minus 5, and this is 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. So if I want to locate a point on this plane in this coordinate system, So I represent the location as x comma y. This you already know,
Yes,
right?
sir.
So let's say if I say 3 comma 4, right? So I go 3 units in x direction and 4 units in y direction. So this is 3
Yes,
comma
sir.
4, right? But what is the special thing about this x-axis? So on this x-axis, what is the coordinate? What is the coordinate of this point?
Sir, it's -5, 0.
Absolutely right. Minus 5, 0. What about this one?
-2, 0.
Minus 2, 0. Good. So similarly, 3 comma 0 and 7 comma 0. So what is the special thing that you are seeing in the coordinates? Yes,
Sir, the y part is 0.
absolutely right. So in the x-axis, y part is 0. So this is what I wanted to get you. So in this x-axis, the y part is 0, right?
Yes, sir.
So now let us talk about the polynomial. So let's say that we have this x and this y, and then you plot the graph of, right? You plot the
Yes, sir.
graph of px. So this is px. So now the points are what? The points are x comma px, right? These
Yes,
points
sir.
are showing me that this is x comma px, right? So what can you tell about this point? What is the special about this point? What
Sir,
is
there will be a
the,
value for x,
yeah, there'd be some value of x, and what would be px at here?
0.
Absolutely right. So px is 0 at this point. What about this one?
Same, sir. Px should be 0.
Px is 0 again, and there px is again 0, and this is px is also 0. So this is what I wanted to tell you about these. So this is what the purpose of these quad. So now you see that px are 0 at this point, this point, this point, and this point. And what
Yes,
do
sir.
we call the px equals to 0? Yeah, so what do we call those x where px is 0?
0 of the polynomial?
Absolutely right. So these x points are zeros of the polynomial, right? So
Yes,
these
sir.
are zeros of the polynomial. Okay. So from the graph, we can say that the points, number of points, the px graph cuts the x-axis, gives the zeros of the polynomial.
Okay, sir.
Okay, so whenever is this part clear, Aisha?
Sir,
Yes, yes.
can you repeat what you said?
Yeah, so I am saying that the number of points, this graph cuts the x-axis, right? So that will
Yes, sir.
give you the zeros of the polygon, right?
Okay, sir.
So in this case, the number of zeros is how much? One, two, three, four, 4 zeros, right?
Yes, sir.
And if I make a graph like this, right? So let's say I have this graph. So what would be the number of zeros?
2, sir.
2, right? So these are the points where this polynomial is cutting the x-axis. So 2, 0.
Yes, sir.
O- Okay, so we'll stop at here, right?
Okay,
And
sir.